Well, hello class. This is the last lecture of the semester. I hope you enjoyed everything we've learned together so far. And what I traditionally do for the last lecture is do an update on industry technology as it has developed since the last time I taught the class. Now, a lot of things have been changing, but I'm going to focus really just on two. The new AI developments and also the qualified health information networks. We discussed foundation AI in the class earlier in the semester, but as it turns out, since I wrote that section, the term really has been updated now to be called generative AI. And you might recall that it uses large language models as the basis for its power. And the cool thing about generative AI is that it can generate new content or novel content from the training materials, but in ways that weren't necessarily the system was trained to do. The way this works is through a predictive measure to sort of guess what the next word would be. And it doesn't really work by just analyzing the data, but rather it just makes guesses based on the model that it built in training. And it turns out there's something called in-context learning that these AI models do, and this mystery of how it works has finally been somewhat solved. You see, these large language models are really good at doing things that they weren't trained on, like producing code. Python code, we'll talk about that in a minute, for example. And companies like Microsoft and Google and others actually use these AI systems as assistants to help their programmers write software faster. It's incredible. And you may have heard about students and schools clashing over the use of these generative AI tools to write papers and such. The really cool thing about these large language models like ChatGPT-3 is that researchers have found that inside these large neural networks, the networks themselves create mini neural networks that they use to train on new topics. This is mind-blowing. Model of the neurons are actually learning how to learn. So it's pretty cool. It's early stages in this research. These models training themselves is something that's really new fundamental science. And you're some of the first students to probably really hear about it in a health informatics or healthcare administration sort of class. This is strictly the world of computer science. It has direct applicability to what we do. The National Library of Medicine collects articles on all sorts of topics that relate to healthcare, of course, in the healthcare community. And one of the articles that caught my attention was how the U.S. government is planning on implementing large language models. Now, it's not the government policy per se, but it's what we're starting to put out there as best practices that caught my attention. This article, references are in the back, talked about if we're going to use large language models, we must make sure that they're in compliance with HIPAA, which makes sense, right? No small feat, however, because we don't really understand how these things work. Remember the last slide. Lessons we learned from implementing EHRs also apply. This goes back to the first week of our class, where the early adopters had to learn how to use these systems and make them useful, and then expand their use across providers as they saw fit. So gaining the trust of the providers and knowing how to use the systems is really something fundamental for the adoption of these LLMs. Probably the most significant thing is the cost of these tools, not just in terms of software licensing, but also how much power, energy they take to run. We talked about that in class. And also the skills that the providers have to run them. So the government is starting to think about how do we leverage these really powerful AI models. Now, the difficulty with these things is that the human biases that appear in the text these LLMs were trained on also exist in the models, because we've ingested it into our systems, and now we're just going to use that information to predict what else we want to say. So as a result, all the biases that are out there are now encoded in these large language models. OpenAI, which owns ChatGPT-3, for example, and all the other providers out there that have these models, have started to try to put on screening tools to prevent the biases from escaping the model. But some researchers have found that if I say I'm writing a piece of software, talked about that earlier, using ChatGPT-3, give me a piece of code in Python that does something, it tricks the model. So there was one researcher that said, tell me all the nationalities that should be tortured. ChatGPT-3 wrote a piece of software that did exactly that. Horrible. And there's another example that there's an interesting Twitter post out there that said, give me a piece of software in Python that says which gender and race would be the best scientist. And you can see right in the code what ChatGPT-3 generated, white males. There was some further training where it also came back with Asians or whites and male, which is a crazy, crazy answer, but it's completely generated from the system, from the text data that it was trained on. We have a lot of work left to do in these large language models, as you can tell. I'll close out the conversation and the class with the celebration that the first QHINs, Qualified Health Information Networks, have been recognized by ONC actually during this semester. On February 23rd, ONC had a big celebration at their headquarters where the first 6 QHINs have executed the TEFCA agreement to begin sharing health data with themselves, each of the QHINs and all their members, and patients who request that data. I've got the references here. You can refer back to the PowerPoint to get them, or here if you like. And lastly, I just want to thank you for being in the class. Please feel free to stay in contact. I'm a resource for you always. You have my emails here, my work email, my Charter Oak email as well. And finally, please follow me on LinkedIn. Connect up. I do post there as well. Follow my channel for the videos that I post, updates as well on YouTube. And then hopefully I'll see you around. Great semester. Appreciate everyone. Take care, and I'll see you soon.